Researchers have recently claimed to have found the strongest signs of extraterrestrial life in data from the James Webb Space Telescope, JWST. But how close is this claim to reality? The exoplanet K218b has been in the news recently, as researchers announced they may have found signs of life in this world. JWST successfully identified 2 chemical compounds in the atmosphere of this planet that are produced by living organisms on Earth. However, the astronomers who presented these results emphasized that they have not discovered extraterrestrial life, but rather have found compounds that could indicate the presence of life. This raises a bigger question: is the James Webb Telescope even capable of detecting alien life? JWST was designed with 4 main scientific goals, one of which is the origins of life and planetary systems. During the conception of JWST, initial design documents and scientific papers discussed this topic, although they exercised caution in predicting what JWST would find. Most writings acknowledged that the telescope would face significant challenges in identifying definitive signs of life. JWST was primarily considered a stepping stone between telescopes like Hubble and Spitzer and the next generation of telescopes that will have the capability to detect biological signatures definitively. Sarah Seeger, a renowned astronomer from MIT, along with colleagues from the US, the UK, and Europe, recently noted in a paper that providing definitive evidence of life on exoplanets with JWST is exceedingly difficult. Definitive evidence of life on a distant planet like K218b is unlikely to be revealed suddenly. This planet is about 125 light-years away. Planetary atmospheres are complex, and this great distance makes them harder to understand. One of JWST's challenges in transmission spectroscopy of rocky and sub-Neptune planets is that it is actually only suitable for planets orbiting M-type red dwarf stars. Because these stars are smaller, the signal from transiting planets in front of them is better received. In contrast, larger and brighter stars can introduce significant noise into the transit signal. The authors explain, since M-type stars are between half to 1/10 the size of our Sun, their transit spectroscopy signals are about 4 to 100 times stronger than those of Sun-like stars. However, M stars have their own specific challenges. The problem is that red dwarfs are more active than Sun-like stars. According to researchers, high magnetic activity in them manifests as star spots, bright regions, and flares that contaminate the spectra. The authors point out that in the well-known TRAPPIST-1 system, the red dwarf star severely contaminated the spectroscopic data. It should be noted that K218b also orbits a red dwarf. This image illustrates how star spots can contaminate light spectra. When light from these spots mixes with the light from the planet's atmosphere, interpreting the meaning of the signals becomes challenging. They warn that interpreting transit spectroscopy signals and reaching definitive conclusions is very difficult. They write, "It may seem exaggerated to use spectral data to deduce a planet's characteristics, such as atmospheric composition, surface, interior, habitability, and existence of life. The observed spectra from exoplanets are heavily averaged signals resulting from complex 3-dimensional physical and chemical processes in the atmosphere. Interpreting such signals is not straightforward, and the science of studying the atmospheres of exoplanets is still in its early stages. However, researchers are making progress." Seeger and her colleagues state that to ensure reliable detection of a biological signal, 3 criteria must be met. Is the signal strong and reliable? Are the spectral features correctly attributed to the desired gases? Are the characteristics obtained from the planet dependable? According to the authors, the potential discovery of dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, in the atmosphere of K218b does not fully meet any of these 3 criteria. The researchers conclude, "We face a bitter reality. It may be that we will never definitively claim the discovery of biosignature gases in the atmosphere of an exoplanet using the James Webb Telescope."